I think I can see them in there. Can you see them? I think if I look really closely, what am I referring to? I'm talking about vectors in a plane. No, not this type of plane. I mean a Cartesian plane. And that's what today's video is on. Forgive my stupidity. Okay, so the Cartesian plane that we're talking about, and thinking about the position of that point there and as a vector. But first of all, its position would be 3, 2. So it's moved 3 in the horizontal direction and 2 in the vertical direction. So we can think about that as having two components, an x and a y component, to represent the vector O to P, capital letters, and with the arrow, that's our vector. And the way we'd represent that, there are two ways to represent that. Notice the square brackets here, 3 in the first position, and that's usually what we're expecting whenever we're dealing with the Cartesian plane. That represents the horizontal component, and this 2 is in the y position, the vertical component. Now for the South Australian students, that's how it's represented in SAIS, so my colleague tells me, for Year 12 Specialist Maths. But in the textbook that we tend to work with, in the Hazy textbook, it's often represented with round brackets and written vertically. So just be interchangeable between the two. Don't get too caught up in one or the other. How have we used that word unit before? We've used it in unit circle, for example, and it's the equivalent of 1. So the vector I here has a horizontal component of 1 and no vertical, well, the vertical component is 0, so it's just a horizontal vector there. What's its length? I probably already said it, it's 1. And J is the letter that we use to represent the vertical unit vector of 1, if you like. And so let's go back to the one we were talking about before. Let's break that up into some horizontal components and some vertical components. How many of each of those do we have? So the vector O to P is represented by 3i of those vectors I, where it's a base unit vector, and 2j. So this form here in the yellow box over here, that's called component form. That's when you're looking at the two parts of the vector, the horizontal and the vertical component, and you're just looking at them. And then when you put it into this form over here, so you're using the components, but you're also including the unit vector there, the I and the j. So that's unit vector form and component form. So two vectors are equal if their components are equal. Let's have a look here. So if we're asked to write vectors O to A and CB in component form and in unit vector form. So the way I do this is OA, so capital letter O and A and an arrow, in component form. So having a look at that, here's O, we have to go 3 to the right. So we would write that 3 there and 1 up. I'll do it with the curved brackets there. And so that's component form. So unit vector form is you take that 3 and you write an I next to it, the vector of I with the arrow, and add on 1 lot of the unit vector j. We don't have to write that coefficient of 1 out the front, as we know. And there we have the vector OA. What about the other one, CB? The components of CB are from C across to B, 1, 2, 3. We have a horizontal component of 3 and a vertical component of 1. So the unit vector form is 3i of the vector I plus 1 lot of j. Now, what do you notice about your answers in A? So we would say that the vectors OA and CB are equal, because as the definition up here said, they're equal if their components are equal. It doesn't matter that they're in a different position, the vector component is equal. Okay, thank you for joining me for vectors on the plane. Next time we'll have magnitude of vectors. Make sure you subscribe. Thank you.